Welcome to the Ready Academy. Tools for teaching, tools for learning, tools for life. In this video book, we cover simple machines. This content was produced with AI assistance and reviewed by a human instructor. We'll begin with an overview of this video book. How could a single engineer in 3rd century BC Sicily claim he could move the earth and have his contemporaries believe him? When Archimedes wrote to King Hiero II that given the force, any given weight might be moved, he was not boasting about brute strength. He was describing a mathematical relationship between force, distance, and work, a trade that still governs every crowbar, ramp, pulley, and screw in use today. That trade is the single idea behind the 6 simple machines: the lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. A simple machine is any device that changes the magnitude or direction of a force while conserving work. Push a 100-kilogram crate straight up a 1-meter step, and you must exert nearly 1,000 newtons over 1 meter of motion. Roll it up a 5-meter ramp instead, and the required force drops to roughly 200 newtons, but you must now push through 5 meters. The product of force and distance, the work, is the same in both cases. Machines never give you something for nothing. They trade force for distance, or distance for force, but the total energy transferred stays fixed. Figure 0.1. A side-by-side illustrated panel of the 6 classical simple machines, each labeled: a crowbar lifting a stone, lever; a wooden doorknob and spindle, wheel and axle; a single pulley with a rope and bucket, pulley; a ramp leading to a loading dock, inclined plane; an axe splitting a log, wedge; and a wood screw being driven into a plank, screw. This video book follows the idea historically and physically. Here is what this video book covers. Section 1 traces the history of the simple machines from the oldest hand axes through Archimedes' proof to Galileo's crystallization. Section 2 establishes the bookkeeping rules: work, mechanical advantage, and efficiency. Sections 3 through 8 derive the ideal mechanical advantage of each machine in turn: the lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. Section 9 shows how simple machines chain into compound machines, multiplying both advantages and inefficiencies. And Section 10 connects all 6 geometries to modern engineering, from robot linkages to hydroelectric turbines. The treatment is deliberately math-heavy. Every claim about how easy a machine feels is tied to a number, and every number is tied to a free body diagram or a torque balance. Galileo crystallized the principle in the late 1500s. Machines do not cheat nature. They transform energy. They do not create it. 2,000 years after Archimedes, that single principle still governs every tool you will ever pick up. That wraps up Introduction. Next up, Section 1, a short history of the simple machines. If you found this helpful, like and subscribe, and support the channel.